Today we're going to complete the Carts and Masses Lab Part 1, and you should have already filled out your journal, including a prediction. I predict that increasing cart's mass while keeping the hanger constant will blank, increase or decrease its acceleration because blank. And you go on and have your own reason there. You should also have completed your data chart where you have pre-filled in the cart mass and the hanger mass. As a pre-lab, you need to fill in the hanger weight today, and of course remember that the hanger weight is just its mass times the acceleration due to gravity, and you should also predict the acceleration for the cart mass system. Remember that the acceleration, when we're talking about the mass, we need to include both the cart and the hanger because both of them are moving at the same time. So this first one is 0.250 kilograms plus 0.050 kilograms. That's 250 grams plus 50 grams is 300, and so on. So you're going to have to predict the acceleration, not the total mass. We know that's pretty easy. Predict the acceleration right here so that we can compare it to our measured acceleration. After that, you're going to do your data collection, and your teacher will explain how to do that if you are face-to-face, and if you are not face-to-face, the data collection will be done on a video which you're going to watch as well, and you'll get that filled in right there. After that, you're going to graph your acceleration versus mass. So I have a piece of graph paper here which has been cut to fit down in this corner right here, which will glue down to this blank space after we filled it out. First thing we need to do is put our axis labels on here, and I'm going to draw my axis labels with about 3 boxes of space before I get my axis line so that I have room to include my labels and my numbering. So there we go. So I've drawn the axes. The axis in the y direction is the acceleration. So I'm going to label that acceleration, and I of course have to have my units, meters per second or meters per second squared. And then on the x-axis we have our independent variable, which is our system mass, which is the mass of the cart plus the hanger, and that will be in kilograms. And we also need to put our numbers in here. Now the numbers are going to be fairly straightforward. They're not going to vary a lot, so we should be able to put in our numbers fairly straightforward. It won't go over 2. So I'm going to have each one of these be equal to 0.2. So I go up 1, 2, 3, 4, 5 boxes, and I'm going to call that 1.0 meters per second squared. And then 1, 2, 3, 4, 5 boxes more, and that'll be 2.0 meters per second squared. And of course this down here at the origin is going to be 0 in this case. The same will be true for our mass. The origin will go all the way to 0 here. We don't have to, but we will in this case. And our mass, we can see the mass of our cart is 1 kilogram, and then plus the 0.05 for the hanger, so 1.05 kilograms. So we've got all of this space to work with here. So I'm going to make it 0.1 for every 2 boxes. So this will be 0.1, this will be 0.2, this will be 0.3, which is our first data point, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, and my last data point will be just a little bit past that, 1.05, so it will be just past that. We also need a title on our graph. All graphs need to have a title. So this graph, the standard title would be just our axis labels, which would make it acceleration versus system mass. Once we've got this complete, we should already have our predicted and our measured accelerations. For our predicted accelerations, I'm going to put those on this graph in red. And our data points, we've got our first data point is 0.25 kilograms plus 0.05 kilograms, so that's 0.3 kilograms. And I'm just going to make up some numbers, and I'm going to say I've got one about here, and then I have another one at 0.55, so that's going to be somewhere in here, and then I have another one at 0.8, so that's going to be over here, and then I have another one at 1.05, so that's going to be over here. And then I'm going to draw a best fit curve, because I know that this is a reciprocal, which means it's a curve that looks like that. And this will be my predicted value in red. Now, remember that these are not real numbers. I've just made this up here. Now, for our next one, we're going to put our measured acceleration. We're going to do that in green. So the values that we have here in the x direction, like 0.3, are going to be the same. It's how high or how low that may vary. So I'm just going to make some numbers up in green. So I've got that one, and then I've got this one, and then I've got this one, and then I've got this one. And I've made all these up, of course. And we're going to now try and draw a best fit curve through this. So there, now I have a red and a green line or curve, the red being the predicted value and the green being the actual measured value. After that, you'll calculate your percent error for 2 points, the first trial and the last trial. So we've got at the two opposite ends of our measurement, we've calculated the percent error. The percent error is the predicted value minus the measured value, and that's in parentheses, you have to total that first, divided by your predicted value, and then multiply by 100 so that you get a percentage. Don't forget your percent sign to indicate that this is not a fraction, because without the 100, this could also be a fraction. So let's put our percent sign in. You're going to do that for trial 1 and for trial 4. When you're complete with, when that's finished, you can take this, and if you want to put some glue right along this edge here on the underside, and then glue that down. Don't fold it and turn this into a pop-up book or anything like that. Just a little bit of glue right there, 2 or 3 dots, and glue it right down in that corner. Then you're going to take a picture of your entire journal and upload that picture. You're going to have to actually take 2 pictures, one picture to include your graph, and then one picture to include these analysis questions, which you're going to do on your own. So answer these analysis questions before you upload your picture of your graph. When you're finished with all of this, you're going to begin setting up your journal for tomorrow, and you need to follow those instructions and get your journal set up for tomorrow. On Friday, there will be a quiz over both parts of this lab. If you are in pre-AP, one of the things that you need to also consider are sources of error. Remember, not mistakes. Sources of error are a very important part of your lab procedure, and you're going to put those in the lab quiz that we're going to have on Friday. And after you've completed all of this here and finished your lab journal setup for tomorrow, you are done for the day.